It was called the National Advisory Committee for Aeronautics, a new independent agency created by President Woodrow Wilson in 1915. Its job, make the United States a world leader in the field of aeronautics. In less than 3 decades, these early pioneers in aviation and those who followed would be called upon to think through problems a million miles away and do it with boldness and vision. By the mid-1950s, NACA had modern wind tunnels and was moving into the area of rocket and satellite research. Then on October 7th, 1957, the U.S. and the rest of the world were greeted by the sounds of Sputnik 1. The Soviet Union had placed the first artificial satellite into orbit. It would not be until early the following year that America's satellite, Explorer 1, successfully orbited the Earth and discovered a dense belt of radiation surrounding our planet. Who would have believed at this early stage that we would one day move outward from the thin ribbon of Earth's atmosphere to the very edge of our solar system and beyond? Project Mercury, the country's first manned spaceflight program, was given the go-ahead just 1 week after NASA was formed on October 1st, 1958. Seven test pilots were selected to become astronauts. Donald K. Deke Slayton, Alan B. Shepard, Walter M. Schirra, Virgil I. Gus Grissom, John H. Glenn, Jr., Leroy Gordon Cooper, and Malcolm Scott Carpenter. The 7 new astronauts spent months and months undergoing rigorous testing and training. While they were being trained, several monkeys took check rides in the new Mercury spacecraft. Meanwhile, the orbiting of unmanned satellites became more and more commonplace. And weather watchers like Tyros found a permanent place in our daily lives by improving weather forecasting capabilities. On August 12, 1960, President Eisenhower took part in the first transmission of the Echo 1 communications satellite.
This is President Eisenhower speaking. It is a great personal satisfaction to participate in this first experiment in communications involving the use of the satellite balloon known as Echo.
On May 5th, 1961, astronaut Alan B. Shepard made America's first suborbital flight. Project Mercury was underway.
2, 1, 0. All right, lift off and the clock has started. Yes, sir, reading you loud and clear. This is Freedom 7. The fuel is go. 1.G. Cabin at 14 psi. Oxygen is go. Cabin pressure is holding at 5.5.
Soon after Freedom 7 landed, President John Kennedy gave NASA an ambitious new space goal.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
After Alan Shepard and Gus Grissom's test flights, 4 other American astronauts orbited the Earth in Mercury spacecraft, starting with John Glenn. He was followed by Scott Carpenter, Wally Schirra, and Gordon Cooper.
You are go. Water systems, go. Range operations, Mercury capsule, go. All pre-start panel lights are correct. The ready light is on. Eject Mercury umbilical. Oil evacuate. Mercury umbilical clear. Mercury evacuate, lights on. All recorders to fast. T-minus 18 seconds and counting engine start.
May the we with be with you, Thomas.
8, 7.
As NASA geared up to respond to the lunar commitment, it became clear that new management techniques for handling far-flung systems manufacture and final integration would have to be developed. Clear also was the fact that state-of-the-art electronics and computers would be pushed to the limit. Unknowns about the moon were numerous. Such things as whether an astronaut would sink into dust over his head were a real concern. Lunar impact studies like these were carried out in an attempt to learn. Researchers fired projectiles simulating meteors hitting the moon into sand-like and rocky materials, and then measured how much material was thrown out by the impact. This animation shows how scientists believed the huge crater Tycho was formed on the moon, a crater 54 miles wide. A series of picture-taking Ranger spacecraft slammed into the moon. Then, 5 lunar orbiters photographed over 90% of the moon's surface, including the never-before-seen backside. We saw a glimpse, too, of our own planet from lunar distance. But most important of all, it made possible the selection of landing sites. Six Surveyor spacecraft made soft landings on the moon over a 2-year period. A robot arm dug a trench. Lunar soil was like wet sand. Men and equipment could safely land there. Panoramic views like these were assembled from hundreds of individual photographs. Communications via satellite exploded into a whole new industry. That first live intercontinental transmission by Telstar 1 was just the start.
La chansonnette après l'effet.
Relay, designed to transmit television, telephone, and high-speed data. Syncom, with Olympic coverage from Tokyo, and Early Bird 1, all were follow-ons to previous research and development.
5, 4, 3, 2, 1. Take it. Because of the following special one-hour broadcast, programs previously scheduled at this time will not be seen.
Since rendezvous, docking, and having astronauts work outside the spacecraft were critical to lunar missions, NASA began Project Gemini. Using the Mercury capsule as a model, the Gemini spacecraft was enlarged to hold a two-man crew. Gemini would provide design answers for the upcoming Project Apollo. And who could ever forget that spectacular first walk in space made by astronaut Ed White? Ten times pairs of astronauts flew into orbit, walking in space, rendezvousing, and docking. Gemini had blazed a trail for Project Apollo, the three-man spacecraft that would carry astronauts to the moon. More than 8 years were poured into designing, building, testing, and preparing astronauts, rockets, and spacecraft for the first lunar landing. Here's a visual look back at some of that preparation. In 1967, tragedy struck. The nation mourned the loss of the crew that would have flown the Apollo spacecraft on its maiden voyage. Astronauts Gus Grissom, Ed White, and Roger Chaffee died in a flash fire as they were conducting pre-flight tests on the launch pad. The manned flight schedule was delayed 18 months as the command module underwent redesign. While these changes were being made, the parts and pieces needed to assemble the giant Saturn V moon rocket came together at the Kennedy Space Center, Florida. Everything associated with the Saturn V was huge. The rocket itself, the building where it was assembled, and the crawler transporter that carried it to the launch pad. The fully loaded Apollo Saturn V was 363 feet tall. Its main engines alone generated 160 million horsepower, and its fuel pumps pushed fuel to the engines with the force of 30 diesel locomotives. As Saturn V lifted off Launch Complex 39 for the first time, it weighed more than 2,800 tons. The pace quickened. Starting with Apollo 8, every Saturn V launched had a three-man crew. Two days before Christmas in 1968, astronauts Borman, Lovell, and Anders became the first humans to pass out of Earth's gravitational control and into that of another body in the solar system, the Moon. The hardware to travel to the Moon had worked well, and landing sites looked good. Our Earth seemed small and fragile, hanging in the vastness of space. This view of ourselves from lunar distance would change the way we think about Earth for all time. It raised profound questions, especially those associated with the Earth's finiteness and unlimited resources. The next two flights, Apollos 9 and 10, would continue dress rehearsals for the first lunar landing. All systems were indeed ready. Astronauts Neil Armstrong, Edwin Aldrin, and Michael Collins would make the historic journey. Next stop, Tranquility Base.
2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower cleared.
We got a roll program.
Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on proper heading.
Houston, Apollo 11 is calling you on the high gain. How do you read, over?
Roger, loud and clear on the high gain.
Eagle, you're looking great. Coming up 9 minutes.
We're now in the approach phase, everything looking good. Altitude 4,200.
Houston, you're a go for landing, over.
40 feet down, 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward, drifting to the right a little. 20, down a half.
30 seconds.
Forward, just good. Right. Contact light. Tranquility Base here. The Eagle has landed.
That's one small step for man, one giant leap for mankind.
Across the country and around the world, the Apollo 11 crew were welcomed back as heroes. Meanwhile, more than 100 scientists from here and abroad began intensive studies of the lunar samples. Before Project Apollo ended, 6 additional flights to the moon were made, and all but one were highly successful. Skylab was the next manned spaceflight. Launched first was a 2-story orbital workshop. Then the first of 3 3-man crews departed to meet, join, and begin living in the orbiting laboratory. Those crews would stay 28, 59, and 84 days respectively. One of the major objectives was to find out if astronauts could physically withstand extended stays in space and continue to do useful work there. The answer was a resounding yes. Experiments in astronomy, Earth resources observations, materials processing, and crystal growth all proved highly successful. Then ASTP, Apollo-Soyuz Test Project, a joint endeavor between the Soviet Union and the United States. The mission called for a mutual docking and crew exchange to develop the necessary equipment for international space rescues. Before, during, and after Apollo, Skylab, and ASTP, NASA's unmanned planetary programs were giving scientists exciting new glimpses into the history of the solar system, from early explorers to the infrared astronomy satellite. 7 Mariner spacecraft flew by the planets Mars, Venus, and Mercury, sending back a stream of pictures and data. 10 Pioneer spacecraft did likewise, including Jupiter flybys and probes through the atmosphere of Venus. Pioneer 10 became the first man-made object to leave the solar system. Atmosphere physics, astronomy, meteorology, and geodesy. These are just a few of the scientific disciplines studied by dozens of Explorer-class orbiters through the years. Hundreds of sounding rockets have probed the atmosphere above where balloons are effective, but below the area that satellites fly. Biosatellite was sent aloft to answer basic biological questions. Will cells divide normally while weightless? How does zero-G affect plant growth? Would radiation and weightlessness be a hazard on long-duration space flights? Everything from plants to primates were orbited aboard biosatellite to find out. There were the OGOs, orbiting geophysical observatories that blossomed out like giant dragonflies in space. OSO, orbiting solar observatories, studied our sun and its influence on Earth. In the last 25 years, our orbiting astronomical observatories have radically changed our view of the universe. We now see a dynamic universe of quasars and black holes and other extraordinary objects, of cataclysmic forces causing the birth and death of stars, of billions of galaxies wheeling in the immensity of space. We looked back at planet Earth with Landsat remote sensing satellites. Crops, forests, pollution, all can be photographed in great detail to help us better manage our Earth's resources. The Viking program was a systematic effort to investigate the planet Mars. 2 separately launched Viking spacecraft, made up of a pair of orbiters that would photograph from above the planet, and twin landers built to descend to the Martian surface, spent 11 months and 420 million miles traveling to the mysterious red planet. The lander's robot arm conducted chemical and biological tests on the soil.